Knowing about matrix multiplication, we can write a system of equations as a matrix equation. And I'm going to go ahead and just write this one out and show you why it works the way that it does. We start with a coefficient matrix, the coefficients of all the variables. Okay, 2, 3, and 1, those are the coefficients of x, y, and z. And then 3, 3, 1, and then 2, 4, 1. Okay. And then if we take that coefficient matrix and multiply it by a column matrix of those variables, okay, then we can set it equal to a column matrix of what these were, those numbers. Okay. This here is equivalent to this system. And let me just point out why. First of all, let's look at the dimensions. This is a 3 by 3 matrix, 3 rows and 3 columns. This is a 3 by 1 matrix, 3 rows and 1 column. So because these inner numbers match, we know that we can multiply them, and we end up with a 3 by 1, which is precisely what we do end up with. Okay? So first of all, the numbers check out as far as a dimension. Then we can actually go through and look at the multiplication. Okay? If I take my first row and multiply by the column here, I get 2 times x and 3 times y and 1 times z. And then I add those together. Okay? Well, and what does that equal? The first entry of this, which is 4. Note that that is just this first equation. Same thing, I take the second row times the first column. That will give me the second row and first column. 3 times x plus 3 times y plus 1 times z equals second row, first column, which is 2. That is the second equation. And of course, the third equation will work out that same way. So we can write a system of equations in matrix form. This right here is called a matrix equation. Matrix equation. And we will see later why this is a useful way to write the system of equations. Okay, we know how to solve system of equations by hand, but we're going to have a technique that uses matrices that actually will simplify some work for us in different contexts.